Hi, and welcome to our last video on atmospheric dynamics, specifically looking at balanced flows. And we're going to talk about the last two kinds of winds. We've gone through the geostrophic, gradient, and friction layer winds. Now we're going to look at cyclostrophic and inertial winds. So first, let's take a look at the inertial wind. The inertial wind, if we start out with the horizontal equation of motion, and we're looking at curved flow, so we threw in the centrifugal acceleration there on the left-hand side. We're going to get rid of friction, and we're going to get rid of pressure gradient. So friction means that this is going to happen a little bit higher in the atmosphere above the boundary layer. And then pressure gradient, that's kind of strange. You get rid of pressure gradient, and the equation you get is this, is V squared over R is equal to F times V. And the V's, one cancels out the other, and all you have is the wind is a function of the Coriolis parameter on the radius. So for the wind to get going, for the inertial wind, for there to be an inertial wind, the wind has to be moving initially, because what makes wind go really is the pressure gradient. The wind starts moving as a result of a pressure imbalance, and then all these other forces start acting on it. So let's say that the pressure gradient is really weak. Let's say that the wind was moving and it moved into a region where the pressure gradient was really weak. And so the wind just keeps moving because of momentum. And as it moves to a different latitude, so the Coriolis changes and the centrifugal force changes as a result of the strength of the wind. So what this results in is a circular motion. You get the wind just moving around circularly, the radius changing because of the changing Coriolis, and also the wind speed. If the wind speed changes, then the Coriolis will change as well as the radius. So as I said, the change in latitude will result in a change in the radius and the change in the flow. You see this sometimes down at lower latitudes, in other words, down somewhere about 10-15 degrees of latitude. And the reason is pressure gradients tend to be kind of weak down there. And then the wind is moving along, but you'll start to see kind of inertial oscillations or inertial motions in the wind. Another kind of wind we're going to talk about is the cyclostrophic wind. And with the cyclostrophic wind, we're going to get rid of Coriolis. Coriolis acts on air traveling over great distance, great velocities, so we're going to get rid of that. And we're also going to get rid of friction. And we're going to say that friction is not really that important, it's kind of small. So what we are left with is a balance between centrifugal acceleration and pressure gradient. So if we solve for the velocity, this is what we get. We see the velocity is a function of the radius and also the pressure gradient, also the air density, but we can focus on the radius and also the pressure gradient. So the greater the pressure gradient, the greater the velocity, and the bigger the radius, the bigger the velocity. And this is the equation for a tornado, believe it or not. The bigger the radius, you're talking wedge tornadoes, ones that are, half mile to a mile wide, their velocities are just incredible. And then also it's the pressure gradient. In other words, the drop between the air inside the tornado and the outside of the tornado. If that gradient is huge, then you're going to have a very strong wind around the tornado. It can be cyclonic or anticyclonic, but that is the equation for the tornado. So in summary, here are all the different kinds of winds, all the assumptions, the balance of forces for each type of wind, and then what type of area that you find this kind of wind. So for example, the geostrophic wind, the assumptions are there's no friction and no acceleration. It's a balance between pressure gradient force and Coriolis, and you usually find it in the middle of the atmosphere where the winds are not curved and where it's not accelerating. So you can look at all the other ones, and this is also in the PowerPoint presentations that are at Easy LMS. Thanks for bearing with me.